do this. Algebra 2, lesson 4-3, divide cubics, not quadratics. That was our last lesson. Divide cubics by linear expressions. Today's date is Tuesday, November 3rd, 2020. Our objective today is to, Jessica.
Use long division or synthetic division to divide cubics by linear expressions.
There it is. Yeah, and then the word cubics, it just means it's something to the power of 3. So nothing bigger than that. I mean, you can use synthetic division and long division with polynomials to the degree 7, or degree 11, degree 1,000. But for the sake of just keeping things simple and making sure you understand the process, I'm going to go up to cubics. I don't know if I ever go to polynomials. Yeah, Andres.
So would quintic be to the power of 5?
Quintic is to the power of 5, yeah. And then quartic is to the power of 4. Quartic. It's like quartz, but quartic. Yeah, so my advice, make sure that you leave a 0, a placeholder 0 value if there is a degree that is missing. Here is an example where one of the degrees is missing. If we label the degrees, I can say this is degree. I'll write the degree underneath. This is a degree 3 term. Why? Because it's to the power of 3. This is a degree 1 term because it's to the power of 1. This is a degree 0 term because it's like x to the power of 0, which means it's not there. That's a degree 0 term. Notice that it went 3, 1, 0. We missed something. We need a placeholder value. The way that I would rewrite that is it's x to the power of 3 plus 0x squared plus 2x minus 1. I have to have a placeholder value when I'm doing either synthetic division or long division, both of them. I need to have a placeholder value. All right, so I want to practice using both long division and synthetic division on this example. And we have a lot of stuff to do today. I'm going to do example 2. We have example 3 on the back and example 4 on the back. They get harder and harder and harder. Welcome to Algebra 2. All right, so long division. Give yourself room if you're following me with the notes because long division takes about this much space. So try to cram it into the long division side. Synthetic division doesn't take too much space, so it's okay if you impose on its area. Again, we are dividing by x minus 2. So I'm going to say, and again, skip a line because our answer is going to be written right here. Skip a line and say x minus 2, and that's going to go into this. And then check, do we need a placeholder value? It goes degree 3, then 2, then 1, 0. We do not need a placeholder value. So I'm going to write 3x to the power of 3 plus 4x squared minus 12x minus 14. And I still need to have room for my remainder. My remainder will be written right there. All right. It's been 2 days. Well, I mean, you might have done long division yesterday for the quiz, but I doubt it, unless you're getting synthetic division wrong. For long division, first step is to do what? Charles. Just match the first term, yeah. So how do I get 3x to the power of 3 then?
Multiply it by 3.
By
So you put the 3 over the 4 squared. And multiply, 3x squared.
3x squared. Because multiplying by 3x squared times x will give us 3x to the power of 3. I'm going to pause here because it's kind of the key step in solving this. All right, and then to finish it off, Charles, go ahead and distribute your 3x squared into this x minus 2 linear term.
It should end up as 3x cubed minus 6x.
There it is. And let me zoom in here because there's not really a good reason for me to stay zoomed out. All right. So, Charles, you may no longer speak until everyone has spoken. Sorry, Charles. We're trying to get everyone in here now. Next, what do I do? What?
Well, you're going to subtract 3x cubed minus 6x squared from 3x cubed plus 4x squared, or like multiplying both the terms by -1. So basically subtracting, which will then cancel basically the 3x cubed, so those are no longer there. And when you subtract a negative, it's basically just like adding in. So that'd be 10x.
Well explained. Can't put it any better than that. What do I do next? And again, Wyatt, you may no longer participate. What is the next step? I see one hand raised. Two hands raised. Jose.
We gotta find something that matches up with 10x squared.
Close. That's you're 2 steps ahead. I want to do just 1 step.
Oh, so you break down
Bring down the negative 12, exactly. And then you can say your step as well.
and then you find something to cancel out 10x squared.
How do you get 10x squared from x?
So you multiply
By
by
10x. All right, I need someone else to distribute and then subtract. Jade.
It would be 10x squared minus 20x.
You distributed it correctly and then subtract.
The 10x squared, the total, would then cross cancel, and you would be left with 8x.
Yep, because minus plus 8x. Thank you, Jade. So Jose and Jade now can no longer participate until everyone is in. Yes, Charles. Ooh, good question. And then this is open to the entire class, even people that have participated. Shouldn't it just be 8? Why do we have an x and we have subtracted the x's away? Someone answer. Jade.
Because it's the number of x's. There are 20 x's, there are 12 x's. If you have 20 and you're subtracting 12 from it, you still have 8.
Yeah, another way of putting that is if I had 20 apples and I took away 12 apples, I still have 8 apples. Yeah. Thank you, Jade. All right, next step. Sorry, Wyatt. I know. I feel bad. Jenny. You do indeed bring down the negative 14 right here. And still on Jenny, what do I need to multiply this x by in order to get to 8x? Close. 8x times x is 8x squared. So the question again is, what times this x will give us 8x? It's even easier than you're thinking. So 2 times x is 2x. How do I get 8x? You said 8x times x is 8x. It's not 8x, it's just 8, exactly. Just 8, a positive 8 here. And someone else to distribute and then subtract. Sorry, Wyatt. Sorry, Jade. Someone new. Jenny can no longer participate. I'm waiting for everyone to get in. And it's going to be a cold call in 3, 2, 1. Cohen, distribute. What is 8 times x? Minus 16, perfect. And then subtract. Perfect. Beautiful. There it is. Thank you, Cohen. All right. And then my final step. I can zoom out here a little bit. My final step. Sorry, Wyatt. I'm basically done. That's a remainder of 2. But what do I do with that 2? The binder does not help. Sorry. The remainder of 2. What do we do with it? In the olden times, we did R2, remainder 2. But we do something a little bit different now. Looks like it's going to be another cold call. Andres, what do we do with that 2?
It's gonna be 2 over x minus 2.
It is indeed going to be 2 over this original x minus 2.
But plus.
And because it's a positive 2, we will indeed put a plus. Yeah, thank you. We have our final answer. Woo! Good job, everyone. Question, Sergio.
So what I don't know, I know that's right, but like what do you have to do with minus and then minus plus?
You always switch the sign. So it's like saying like this. If I have some quantity here and I'm going to subtract 3x minus 7 from this original quantity, what I do is I distribute this negative, which is saying switch a sign to a negative 3x and a positive 7. It's really just distributing the minus sign when I really just wanted to take away from the original amount. Yeah, that's a great question. And it is confusing, I know. Other questions before we move on to synthetic division? Question, yeah.
You could, instead of just displaying it as a negative, you could display it as a negative 1.
You could, yeah. So like distributing the negative 1 out here, is that what you meant?
Yeah.
Exactly, yeah. Other questions? And then on to synthetic division. You know how to do it, and there's only a few people left that can participate now. Same exact problem. So who can help me set it up? It's going to be between Josie, Fernando, Jessica. Have you participated yet? Sergio, have you participated yet? No? So between those 4, I think at the right-hand side of the class, or the left-hand side if you're looking that way. Fernando, thank you.
Wait, what's the synthetic?
Synthetic division, you switch the sign down here and put that in the top left. You write all the numbers. It's a shortcut from yesterday, yeah, or from 2 days ago.
So it's just gonna be, for that bottom one, it's gonna be plus 2 in like that box.
Box for the 2.
And then it's gonna be 3, 4, negative 12, and then
Thank you. All right, Fernando has set up our synthetic division. A little bit easier to write, a little bit quicker. Now that we have synthetic division all set up, I need someone else to tell me how to do at least a few steps. Probably have to call between the 3 right here. Who's it going to be? What's the first step? First step. Jessica seems like she knows. Go for it, Jessica. What do you do with that 3? Try to look at notes 4-2. You go straight down and it's still the 3. Next step, Jessica, how do I get diagonally up and to the right? What do I do with that 3? You do indeed, and you get, ooh, careful. So it's 3 times that original 2 in the top left. So 3 times 2 is 6. Last step before I'm done with you, what am I going to do with the 4 and the 6 now? It's one of those, yep. Which one? You do indeed, and that adds up to 10. All right, then it's just Josie and Sergio. Both of you are going to help me solve this problem. This is the easiest part right now. Just keep continuing Jessica's method. Who wants it? Yes, Josie, go for it. So I'm going to go diagonally up again. So the way that Jessica went diagonally up right here was she took this number 3 and multiplied by 2. You need to figure out how to get from 10 to this number right here. 20, keep going. And you get? What's 20 minus 12? What is 20 minus 12? It is indeed 8. Keep going. Jump diagonally yet again. 16. What's 16 minus 14? 2. And Sergio. Thank you, Josie. Well done. Sergio, you're our last person. Give us our final answer for synthetic division.
So you the 3 becomes x to square.
This is going to be, let me write it in red here. You said 3 is going to be x squared.
Plus 10x plus 3 plus 2 over x minus, yeah, minus 2.
All right. And is that the same answer that we started with? Yes, it does match up. We give ourselves a pat on the back, everyone. Good job, class. And we should be boxing both of these answers. Yes. Yeah, question?
Why would it be 3x to squared for synthetic division? How did he get the 3x squared?
That's a great question. Who can answer it? Wyatt.
Well, the last one is always going to be divided by the original amount, and then you just keep working your way forward. So 8 is just going to be a number, and it's going to be x. Well, 8 is actually an x, it's just x to the power of 0. So 10 is x to the power of 1, and then 3 is x squared.
Yeah, Charles, give us.
The original problem, you have 3x cubed. Just take off one of those powers and it's 3x squared.
Oh, that's a smart way of doing it too. Yeah, nice. All right. Give me a fist of 5. How well could you follow the long division and the synthetic division? I'm seeing 4s and 5s and some people that are voting. Josie's looking in her lap. 5, thumbs up, all the good stuff. Okay, I don't think I've lost anyone. You guys right now, I want you to try example 2. If you do not have notes, grab some paper and try example 2. You get to choose if you like long division or synthetic division. In about 2 minutes, we're going to come and reconvene and try example 2 as a class. I will leave example 3 up if you want to think about it. We'll be back. All right. I need someone to, I'm going to assume that most people did synthetic division. Who can help me set up synthetic division? Everyone's in. Everyone can go for it. Charles.
Actually, I wanted to wait for example.
I can call on you multiple times now. It's fine.
Okay, okay. So you have the positive 3, all right?
Yep.
I mean, left, sorry. And then you have the box right here. And then a 3, a negative 10, a 0, and a negative 12.
Thank you for setting it up. And that was the trickiest part about this problem, is because there needs to be a placeholder for our 0x, because right here, we should have had plus 0x. There needs to be descending degrees, degree 3, then 2, then 1 that we were missing, and then 0. Next volunteer, do all the synthetic division. I'll do a final volunteer to give us the final form. What?
So you're going to bring the first 3 down. That's just going to be 3. And you're going to multiply that 3 by the 3 in the corner, which will give you 9. Add negative 10 and 9 together, you get negative 1. Negative 1 times 3 is negative 3. That's just negative 3 because it's 0. Multiply negative 3 by 3, which is negative 9. And that's equal to negative 1.
Perfect. And final form. Another volunteer. Jose. 3x squared. Minus x, yep. That's simplified because negative 1x is negative x. There it is. Thank you. And I'm going to box it. There's a question asked by one of the students today on should you be doing plus a negative 21 over x minus 3? And the answer is that's mathematically correct, but it's not simplified. The simplified version of that is just a minus sign out front, 21 over x minus 3. Give me a fist of 5 for that first half of the lesson. That's just how do you do division with cubics. Fist of 5 really quickly, one more time. Cubics, how well can you divide them? Wow, they're like all 5s. Josie, Jessica. Cubics, how well can you factor? Example 1 and 2. Jessica, Josie, are we awake? We're still asleep. All right, moving on to example number 3. this polynomial, x to the power 3 minus 3x squared plus 4, I know that one of the factors, I'm telling you, part of the problem, one of the answers is x minus 2. You need to find the rest of the factors. Completely factorize p of x. You need to factor. Factorize is not a word. You need to factor p of x. How? Factor by grouping doesn't work. Factor by grouping is if there's 4 terms, you divide them and create 2 groups. But even if I have a 0x placeholder and I divide them up, there's no GCF. Factor by grouping fails. We need to have a new method. Charles, question. Okay.
Can you just divide the whole thing by x and then do like ninja star?
Good question. Yeah, let's try it, right? Let's divide everything by x. So if we have x to the power of 3 minus 3x squared plus 4, each of these is going to be divided by x. And then this turns into x squared minus 3x plus 4 over x. And we can't do anything with this. This is now to a negative first degree, and that is even harder now to solve. But good guess. That's all about mathematics, right? You take a guess, you try it, and it didn't end up working, but it was still a good path to try to take. So because this whole lesson, Josie, has been focusing on division, we are going to divide. We're going to say, hey, we have x to the power 3 minus 3x squared plus 4. You can use synthetic division still, right, Jessica? And then we can solve using our shortcut, but then we can use that information to continue. This makes sense because if x minus 2 is a factor, if I divide this polynomial by this factor, what I should have left is the rest of the things I need to factor. And then I can keep factoring our answer more and more and more. What we should get, as Charles pointed out, when I divide a cubic by a linear term, I should get a quadratic. I should get something x squared, which everyone in here knows how to factor. That's just a ninja star. Let's try it. Who can help me set up synthetic division? The same 2 now over and over again. That's fine. Okay, what?
You're gonna have positive 2 in the corner, box it. Then you're gonna have 1, negative 3, 0, 4.
4. Remember that trick. There is a 0 placeholder value. Who can do all the math for synthetic division? Go for it, Charles.
So bring 1 down. 1 by 2 is 2. And then negative 1 should be the sum of that. Negative 1 by 2 is negative 2. And then negative 2. Negative 2 by 2 is negative 4. And then that's 0.
Okay, this is super, super important. 0 means there is no remainder, which means we could evenly divide by x minus 2. This is a theorem I'm going to be talking about, I think, tomorrow or either the next day. Very soon, if you can divide by x minus 2, it means this last value should be a 0. If it's not, you have done something wrong for today's homework. In the future, I will be asking you, is x minus 2 a factor? And you will be like, let me try some synthetic division, and 0. Yes, it is a factor. If it was not a factor, I would get a random number here for a remainder. Charles.
Now, can we do ninja star?
Yes, once we convert this back to the polynomial. Exactly. So someone else besides Charles and Wyatt who's been doing the heavy lifting. Yeah, Jose, convert this back. Minus 2, and no fraction, exactly. Which means when I factor this x to the power of 3 minus 3x squared plus 4 is going to be equal to x minus 2, which we just factored out by dividing it out. And what's left over is this x squared minus x minus 2. Now we are going to keep factoring this quadratic, which is an easy thing to do, hopefully, because you're really, really good at doing ninja stars. You saw them in Algebra 1. We reviewed and added on to that in our last unit in Algebra 2. Who can help me do a ninja star? always Charles and Wyatt again. Yeah, let's go, Charles. Go for it.
So instead of being a star, it should be -2 on the top and -1 on the bottom. And then 1 and -2, 2 and -1. So -2, 1.
-2 and 1. And Wyatt, tell us our final answer.
Would be x minus 2, x minus 2, x plus 1.
There it is.
Can't you do something with the x minus 2? Could that be x minus 2 squared?
Yeah, x minus 2 quantity squared. That's also fine. You can write that. Both will be accepted on Khan Academy and quizzes and tests, etc.
That's why I got confused. I was like,
All right, now is a good time to ask questions because that was kind of confusing. Yeah, Jade.
Why are there two x minus 2?
That's a great question. You get a call on who you want to answer.
Why? Because he knows what he was talking about.
That means Charles doesn't?
whoa.
Well, I mean, like, he has answered that problem.
Okay.
The
Charles knows too. Jose knows too. I'm giving you guys a hard time, sorry.
So our original problem, x cubed minus 3x squared plus 4, we couldn't do anything with it, so we factored out x minus 2. So it's like factoring out the GCF. That's like the GCF.
Oh, so
of it.
that is the GCF.
So it's a GCF, and then you have the ninja star.
Oh, okay, that makes sense. I was just confused because it was the same number, so I thought it was like x minus 2 squared, quantity squared.
You can rewrite this answer like that
You can.
if you want, yeah. Question 1.
Can you scroll down so we can start with that example?
Yeah, I can indeed.
I got that.
Are there any questions about example number 3? If there are no questions, then I assume everyone has at least a 3 out of 5 understanding on example number 3. And that means you're ready to at least attempt number 4. I don't see anyone vigorously nodding their head no or asking a question. I will assume that, and I know what that typically does, but try example number 4, whole class. Go for it. I'll be walking around helping. All right, well, class ended and I forgot to record the rest of this video, so here we go. It'll be a little bit faster than you might be used to. Again, you're going to be dividing by x plus 1, which means with synthetic division, you're going to take the opposite of plus 1 and use a minus 1. Our coefficients, they descend in terms of degrees from degree 3 to 1 and 0. So there's no placeholder value that I need. So I can just write out the coefficients 6, 5, -13, and -12. Give some room for numbers, draw my line. What do we do next? 6 drops down, turns into just a 6. Multiply by -1. 6 times -1 is -6. Add down, I get -1. Multiply this -1 by -1, I get a positive 1. Positive 1 plus a -13 is a -12. -12 plus, or times a -1 is a positive 12, and -12 plus 12 is 0. Again, my remainder is 0, which means, yes, I give myself the thumbs up, and I haven't made a mistake. Because if it is a 0 here, that means that it is indeed a factor, that x plus 1 is a factor. So next, I'm going to rewrite out my function. So originally, I don't have to do this, but I'm doing this for the sake of clarity. My original problem was 6x cubed plus 5x squared minus 13x minus 12. How can I factor that? And my answer so far is, well, I factored out an x plus 1, and I like Wyatt's interpretation of this is like the GCF that I factored out, but it isn't precise enough for me, so I'm just saying it is factored out. It's not a GCF, but it is something that I factored out. And what's left over after I factored that out? This resulting number from our synthetic division, which is 6x squared minus x minus 12. Now I need to factor this quadratic, and you might notice that our leading coefficient here is a 6. It is not a 1. It is not a non-numbers, just it indicates that we need to use advanced ninja star. So advanced ninja star, I can do that over here on the left. Here's our advanced ninja star. Remember that 6 times negative 12 goes on the top. That's a negative 72. Negative 1 goes on the bottom, negative 1. And I put a 6x on the top left and right. What two numbers multiply to negative 72 and also add to negative 1 is the question. And you start going through what are all the factors of negative 72? 1 and 72. Okay, that doesn't get to 1. 2 and 36. Okay, again, not 1. You keep going through all the factors of 72, and eventually you'll get to 9 and 8. 9 and 8 get to 72. In order for the addition to be negative, the bigger number needs to be negative, negative 9 and positive 8. Then I need to reduce. So the numerator and denominator of our fractions can both be divided by 3 on the left here. So I can get a 2x and a negative 3. Divide the numerator and denominator here by 2, and I get a 3x and a 4, which means my final answer over here, I still have that x plus 1, which was factored out from the very beginning. I mean, it told us part of the answer right here in the problem. But what's left over is also this 2x minus 3, 2x minus 3, and this 3x plus 4. And we have our final answer. I'll box it. And I got weird lag there. I think it's just Zoom not liking this program. All right. And that concludes Algebra 2 Notes 4-3. And that's the wrong button. Where's the right button?